Hello everyone, welcome to the Gate Engineering online learning classes. In this tutorial, we are going to discuss about the basic signal operations, where we will talk about the time shifting, time scaling, and time reversal property of the signals. So, the usual operations are shifting, scaling, and inversion, and usually we deal with the independent variable as time in the signals. So, we will talk about the time shifting, time scaling, as well as time reversal, or reversal is also called as the time inversion. These are the three property time shifting. Shifting is used to shift the signal either left side or right side. It depends on the signal property. If signal is xt plus t0, it will shift to the left side by the amount of t0. If signal is the xt minus t0, it will shift to the right side by the amount of t0. Similarly, if we have a signal time scaling, it is used for the compression and expansion. It reduce and it reduce and increase the signal width by the amount of a by the factor a. If signal is xat, it is the used for compression of the signal. Signal will compress, its width will reduced. If signal is xt divided by a, it is used for the expansion of the signal. Signal width will increase. We will see in detail one by one. Next, we'll talk about a time reversal, that is basically used for folding the signal. Whatever value we have in the signal xt in the positive side, we will get same value in the signal yt in the negative side. Whatever value we have in the signal xt in the negative side, we will get same value in the signal yt in positive side. So now we'll start from the time shifting property of the signal. So here we have a signal xt. We want to shift the signal by amount of t by the left in the left side or right side. So first we'll talk about the delayed, that is the right shifted signal. The representation of the right shifted signal is the xt minus t. So in this property, x1t signal will be xt minus t. So this is the shifted version of the signal xt by the amount of t towards the right side. So this is called as a delayed signal. But why is this signal is shifting to the right only? So just look at here. If we consider this time is a t1, so consider t1 minus capital T is equal to t. We will have to plot, we will have to map the signal from t axis to t1 axis. So we will have to compute the value of t1 at different value of t. So t1 will be equal to t plus capital T. Now, now you plot whatever value you have at t equal to 0, you will plot the same value at t equal to capital T. Whatever value you had at t equal to capital T, that value you will get at t1 equal to 2t. Whatever value you had at t equal to minus t, you will get the same value at t1 equal to 0. So this is shifting to the right, correct? Now we see the advanced or left shifted signal. Advanced and left shifted signal is represented by xt plus capital T. Now, in the same way, you write here t1 plus capital T is equal to t. Now, you will have to map again t to the t1. So, you will find the t1 in terms of the t minus capital T. So, now you can check whatever value we have at t equal to 0, we will get the same value at t1 equal to minus t. So it is shifting to the right negative axis. Whatever value we have at t equal to capital T, the same value we will get at t equal to 0. So it is shifting to the left side. So this is the concept of the delaying advanced of the signal, or we can say that the right sided signal and left sided signal, or we can say that it is right shifted signal or left shifted signal. If signal is the right shifted, we can represent it by xt minus t. If signal is the left shifted, we can represent it by xt plus capital T. Now we'll talk about the time scaling. Before that, one most important point is that in the shifting operation, time shifting operation, its amplitude and span of the signal, that means width of the signal, will not change. Here you can see that same characteristic of the signal at all places. Only difference is that the time position will change. It will not affect on the amplitude as well as its width. Now we'll talk about time shifting in discrete time signal. In discrete time signal, if we delayed the signal by 3, delayed means right shifted signal, correct? It is represented by xn minus 3. If we write xn minus 3, so it is the delayed signal, it will shift to the right sided signal. So we have signal from minus 3 to minus 3 to plus 3. So after shifting the signal, we will get the yn from 0 to 6. Okay, it is starting from 0, ending at 6. So it is shifted by the 3. Whatever value we have at t equal to 3, n equal to 3, we are getting at 6. Whatever value we had at n equal to minus 3, we are starting from n equal to 0. So this is the shifting property. Now we'll talk about the scaling. Scaling is used for compression or expansion of the signal in time domain. So the compression of the signal is represented by xat and expansion of the signal is represented by xty. In both the signal, we consider a is greater than 1. If a is greater than 1, the signal is represented by xat for compression, xt divided by a for expansion. So here we have a signal xt starting from minus 1 and ending from 1. After that, signal is 0. So if we write xt divided by 2, so the signal is xt divided by 2, which is the expansion. Here you can see expansion t divided by a by factor of a. So if a is greater than 1, here a is equal to 2. So this signal will expand by factor of 2. Here signal was starting from minus 1, it will start from minus 2. Previously signal was ending at 1, now it is ending at 2. So now you can see this is the width of the signal. Now its width is increased. So width is expanding, width is increased. So that's why it is called as expansion. Now, but why we are getting expansion of the signal by t divided by a? In the same way we visualize here, write t by 2 as t1 divided by 2 is equal to t. We will have to map the signal from t to t1. So t1 will be equal to 2t. So here we are multiplying the t by 2. So here minus 1 in the xt. So in x1t or xt divided by 2, it will start from minus 2. So twice is multiplying through the whole axis. In the same way, x2t is the representation for compression. Compression means the reducing the width. In the compression, signal width will reduce by amount of 2 because it is compression by 2. So if you write twice t1, if we write twice t1 is equal to t, we will get t1 is equal to t divided by 2. Now we will map the t axis to the t1. Whatever value we have at t, we will get at a half value. So signal was starting at t equal to minus 1. It will start now minus 1 by 2. It will start now minus 1 by 2. Here we can see. Similarly, it was ending at 1, it will end at 1 by 2. That's why its width is reducing. So this is the concept of the time scaling as well in the continuous time signal. Now I will talk about the discrete time signal. In discrete time signal, okay, we have a value in the discrete time signal only integer index, So if we write twice of n1 is equal to n, we will map n1, we will map n to n1. So n1 will be equal to n divided by 2. So if we substitute, first we see this is 0, this is 1, this is 2, this is minus 1, this is minus 2. Okay. So important thing here is that whatever signal we have at n axis, we'll get at n divided by 2. But we always use the integer signal, integer time index. So at n equal to 0, the same value will get at n1. For n equal to 1, we will get same value at n1 equal to 1 divided by 2. But this is not defined in the discrete time signal. In discrete time signal, only integer values are defined. So it is not defined for odd values. For our odd value, we will not get. But only for even value, we will get. If n equal to 2, we will get 1. We will get n1 will be 1. So value of the 2 we will get at n1 equal to 1. Similarly, for minus 2, it will come at 1, minus 1. Here you can see that whatever value we had at n equal to 1 or minus 1, that is not plotted in the x2n because of n divided by 2 will not be integer for n equal to 1. And it is not defined in the discrete time signal. Now, come to the expansion side. Expansion is represented by n divided by 2 as we already know. So we can write it as n1 divided by 2 is equal to n, or other terms n1 will be equal to twice of n. Correct? So now see, whatever value we have at n equal to 0 is 1. Same value we will get at n equal to 0 in xn divided by 2. So now here for n equal to 1 we have some value. Let's see, this is 0.75. This value you will get at twice into 1 means at 2. So at 2 you are getting the same value. For n equal to 3 you will get this value at, for n equal to 2 you will get this value at n equal to 4. So this is the 4. So what is happening here? You are not getting value at odd numbers. You are not getting value at n equal to 1. You are not getting value at n equal to 3. So these value, that's why it is 0. It is not defined. It is 0 here. You will get only even multiples of the n. Okay. So what value you had at n equal to 1, you will get at n1 equal to 2. Whatever value you had at n equal to 2, you will get at n equal to 4. Is that similarly in the negative side? This is at n1 equal to minus. This is at n equal to minus 1. You will get at minus 2. This is at n equal to 2 minus 2. You will get at n equal to minus 4. So this is the concept of the compression and expansion in discrete time signal. So its pattern is little bit differ in this case, but in continuous time signal you always expand the signal. Now come to the time reversal. In the time reversal, signal is represented by x minus t. So this is the xt, and yt will be reverse signal. Whatever value you have at t positive side of the signal xt, now the same signal we will get in the negative side in the yt. Whatever value we have at negative side in the xt, we will get same value in the yt in the positive side. So here in the negative side we have 0, nothing here, so we will not get anything in the positive side in the yt. This box is present in the xt in the positive side, the same box it will be present in the yt in the negative side. This is the reversal, yn equal to x minus n, and this folding across the y-axis here near the origin, y-axis. Now in the discrete time signal, if we write this minus n as minus n1, we write this minus n is minus n1 equal to n for this n. So we'll get n1 equal to minus n. So we see this is the xn. For n equal to 1, you will get the same value at n1 equal to minus 1. Whatever value we have at n equal to 1, you will get same value at n1 equal to minus 1. Whatever value we have at n equal to 3, we are getting same value at n1 as n1 equal to minus 3. Whatever value we have at n equal to minus 3, we are getting the same value in the n equal to 3. So it is just folding, okay, mirror image of the signal across the y-axis. Now we'll solve some problem here based on the shifting and scaling property. This signal is given defined between 0 to 4, and out of this range this function value is 0. Its maximum value is 3 here. Now we'll have to plot xt minus 2. This t minus 2 is the right shifted signal. It will start from 2. It will start from 2, the same pattern, and at 6 like that. So here you can see that it is starting from 2 and ending at 6. Now for x2t, x2t is the compression. x2t is the compression. It will reduce the width of the signal by factor of 2. So you can divide by 2 here. You can divide by 2 here for everywhere. You can divide by 2 here everywhere. So you will get 0, 0.5, 1, 1.5 and 2. So signal will lie between 0 and 2 in this case. Here you can see signal will lie between 0 and 2 here. Now we talk about xt divided by 2. This xt divided by 2 will signal will expand by the factor of 2. Signal will go like this. Signal will go like this. Amplitude will be the same. And it will end at 8. Here you can see. Moving, maximum amplitude is 3 and 8. So this is the time scaling by the factor of 2 in the expansion. Thank you for watching this video.